Hi Barbara, I'm going to run through this problem real fast and hopefully this will help you out. So these are actually pretty tricky problems. I know you said that you could do the problem, but just in case this helps, I'll run through it real quick. You'll notice three terms here. This is not a quadratic, but it kind of looks similar to a quadratic in the sense that there are three terms equals 0. This term here is actually the square of the variable in that term right there. So seeing that pattern, we realize that we can make a substitution. That substitution is going to be, we usually call it u, is x to the 1/3. You get that substitution from the middle term right there. Well, you notice that if u is x to the 1/3 power, then u squared is going to be x to the 1/3 power squared, which using the laws of exponents is just x to the 2/3 power, which appears right here. So okay, let's make that substitution. Here, this first term, x to the 2/3, is just going to be u squared. The 5 is just going to stay there, but the x to the 1/3 is now going to be just u. The 6 stays, the 0 stays. Now this problem is suddenly a lot more manageable, and it looks a lot like a problem that you can do. It's just a quadratic. And the whole point of the substitution was to make it look that way. Now we can solve this quadratic using a number of techniques. You could use the quadratic formula, or in this case, since it's one of the simple quadratics, we can actually factor it. So we factored this quadratic. We're going to get u minus 6 equals 0, and u plus 1 equals 0 if we split that thing up into two pieces, giving us u equals 6 and u equals -1. Of course, it was never our goal to find u in the first place. Our goal was to figure out what x was. So at this point, we're going to take our answers for u, and we're going to substitute back in x to the 1/3 for u. Okay, now we have two little equations to solve for x. And the way to solve each one of these for x is to actually cube both sides of the equation. By using the rules of exponents, this turns into x to the 1/3 times 3. And 1/3 times 3 is just 1. So you just get an x to the first power here on the left side of the equation. Now 6 cubed is 216. In the second equation, we get x equals -1 cubed is actually just -1. So these are our two answers. Now I think you said that your problem was in checking that answer. Let's plug in 216 first. Okay, what this fractional exponent means to me is we're going to take the number 216, and in either order we're going to square it, and then we're going to take the cubed root of it. Now it might be easier to do it in the order taking the cubed root and then squaring. The reason I say that is because 216, if you take the cube root of that, we know actually from the previous step up here that that's going to be 6, but then we still have to square the number. Now this fractional exponent here says we just need to take the cubed root of 216. We would then raise it to the power of 1, which doesn't do anything. But 216, the cubed root of that is just 6. Now the question is this a true statement right here? We have 36 minus 30 minus 6 equals 0. It is a true statement. So we've double checked that answer right there. Now let's plug in -1. That was our other solution. And the question is, what is the cubed root of -1? The answer to the question is actually still -1. The reason being, if you took -1 and you cubed it, you would get -1. I know I'm saying -1 a lot, so that probably became pretty confusing there. But the cubed root of -1 is still -1. Now the cubed root of -1, like I said, is -1, but we still have to square that number because of the 2 right here. And if you square -1, you get +1. So what I'm getting is 1 plus 5 minus 6 equals 0. And that is a true statement, so we've double checked that answer as well. So we can go back and we can say, okay, those two answers are correct, and we can plug those into the answers. Okay, I hope this helped. See you next time.